to, since we're not fooling around anymore, yes? You need to know things about SN1 and SN2, and you need to know the little summaries we did about SN2, okay? Now, when do I have, as far as the alkyl halide is concerned, when would I have an SN1 reaction?
Here.
Hello?
What's the first order?
Yeah, it is first order, but the alkyl halide that is preferred for SN1 is tertiary. Alkyl halide for SN2 is primary. Okay, other than that, we have a secondary.
Yeah.
If we have a secondary, what is it going to do, SN1 or SN2?
You could do both.
It could be either one of them. So we are going to choose whether it's going to do one or the other based on the solvent that we use.
Oh, okay.
Okay? So the preferred solvent for SN1 is? Now look in your notes.
Polyprotic, polar protic, right?
And polar protic are those that,
Got a hydrogen.
like alcohols, water, alcohols, and carboxylic acids.
Correct.
Okay? Of course, a faster reaction is water, second is this, and then carboxylic acids, okay? And what type of solvents are good here?
Polar aprotic.
Polar aprotic, which are
DMF.
DMSO and DMF. Okay? So that is the way you are going to know. The mechanism for this involves what?
Stepwise.
It is 2 steps,
Uh-huh.
but it involves what as an intermediate?
Carbocation.
Intermediate.
Yeah.
Okay?
Go ahead.
Because we have a carbocation intermediate, is there the possibility for rearrangements in
Of
the
course.
carbocation intermediate? Yes, of course. So we, and what else? After we have this carbocation intermediate, what else do we produce in there? The product is going to be what? The product is going to be
Oh,
racemic.
racemic, yeah.
Okay, because of an attack from the top and from the bottom, because the intermediate was a carbocation which is planar. Okay? Yes or no?
Correct.
Outstanding. Let's put you to the test. Oh, by the way, did we talk about leaving groups, which were
Yes.
best and which were-
Yes.
Did we talk about nucleophiles, which ones were good and which ones were not so good?
Uh-huh.
We did?
Yeah.
What are the best nucleophiles?
The ones that are charged.
The ones that are charged and the ones that are neutral are not so good, yes?
Right.
Okay, compared to the ones that are charged, yes?
Uh-huh.
Most of the time, nucleophilicity, that means how good of a nucleophile you are, goes along with basicity. So the stronger the conjugate base, the better the nucleophile, okay?
Mm-hmm.
Now there are bases, or there are nucleophiles that are like this, okay? And there's one. That is like that. Are they the same type of nucleophile?
No. No.
One's is tertiary and
So I have a lot of substitutes. It's gonna be-
Are they the same type of nucleophile?
No.
It's not?
No.
What do you mean? What type of nucleophile is this?
So it's just normal.
Is this called an alkoxide?
Yeah.
Is that what this is called?
Mhm.
Huh? What is it?
alkoxide.
Yeah.
I don't know how you can forget this. I think I said this last time, yes?
Yeah.
This is called an alkoxide.
Okay.
Because this is an oxygen with an R next to it. If it were like this, it would be called a hydroxide. Okay, but this is an alkoxide because it has this alkyl group here. And what is this? This is still not alkoxide.
Alkoxide, but it's
It's an
a
oxygen with a
tertiary.
carbon next to it. So they are both the same. They're both conjugate bases of what?
I'm strong.
So we
Are
pass
we?
it.
They're conjugate bases of what functional group?
Alcohol.
Of alcohols. These are conjugate bases of alcohols, so they are under the same, let's say, subdivision, alkoxide, alkoxide. This alkoxide is hindered, okay? So, we can say that this is a base, or this is a nucleophile.
So
Right.
if it's hindered, it's like weaker.
No, because it's hindered, it does not tend to do substitution reactions. Because when it is attacking, Can it fit?
No,
It can't
okay,
fit.
okay.
So most of the time, when the base or the nucleophile is hindered or very bulky,
Or very
it will
bulky.
not act as a nucleophile. What it is going to do, so not a very good nucleophile. It is going to act like a base. And what do bases like to do?
Proton. Abstract.
Set proton.
Abstract the proton. It likes to take a proton off from somewhere. Okay? And that is going to be the topic of the next conversation, which are called elimination reactions. Now, we're not there yet. Let's do this one.
Sorry.
Provide the product for both of those, something you expect 100% guaranteed on the next test. You guys watch the videos this weekend?
Yeah.
Because I'm gonna tell you, I spent 36 hours downloading one single video. Okay? Because I had it in the Wi-Fi. And I spent 36 hours, so then I got to the roof and bought a cable for 40 bucks. Almost died in the attic. I'm serious. I had some type of reaction in the attic because I didn't fit and because it was hot and I was hyperventilating and I started screaming. And my dad is like, make a hole in the roof. So you better watch the videos. Okay? You better watch them. I mean, some people are not taking my class, they're watching the videos. So, what type of conditions are these? Hello?
SN1?
SN1 conditions? How do you know it's SN1 conditions?
Because it's a solid.
By the way, what type of
Polar
alkyl
product.
halide is this?
Second.
What type of alkyl halide?
Secondary, yeah,
This
because
is
secondary.
secondary. They're both the secondaries.
So we could use
Now, we
either.
don't know what to do because it could be SN1 or
SN2.
So what we are going to do is, based
Look at
on
the
these
solvent,
conditions,
yeah.
we're going to choose whether it's SN1 or
SN2.
SN2. These are conditions
H2O.
for
SN1.
SN1. Why are those conditions for SN1?
Because it's polar product.
It's polar
Polar
protic,
protic.
and what does polar protic do? That it allows this to be SN1. Did I talk about this last time?
No.
Just mentioned it was polar proton.
Yeah, you didn't. Polar product good. Stabilizing ion dipole.
Okay, yes. Well, I did say it.
Yeah.
Okay, what is going to happen is, during an SN1 reaction, what is going to happen is you are going to develop a carbocation.
Cation.
Okay, this carbocation is stabilized by ion dipole forces. Okay? Yes?
Yeah.
Now this is good at stabilizing what?
Stabilizing.
Positive
Yes,
charges?
Polar
More-
aprotic. They're good at stabilizing positive charges, yes?
Right.
But not so good at stabilizing negative
Negative.
charges.
Charges, yeah.
So as a result, this becomes more nucleophilic. Okay? This does the attack more often. Anyway. So, these conditions are what appears to me to be SN1. And if I have SN1 conditions, I have to know that this is what type of reaction? Racemic
Racemic.
is the product. So I am going to draw them racemic, yes?
Yes.
I want you to draw them and
Yeah.
say what they are, R and S. Okay, hurry up. You want to come to the board, do it?
Yeah, we can do it.
Ms. Galindo, do you want to come to the board and do it? No?
hydrogen. Yeah,
I'm
chlorine in
going
front.
to, you go like this, yes?
Mhm.
Yes or no? I'm going to leave that H the same,
Uh-huh.
CH2, CH3, and here,
CH3.
This is a substitution. I'm going to substitute the nucleophile.
Yeah.
The nucleophile is neutral, and it will be this one.
Mm-hmm.
In the first step, this is going to add to the carbocation,
Right.
and it will be charged. It will be protonated. It will be a protonated alcohol. The
So to
rest
give
of
it
the water
positive.
that is in there is going to pull the proton off, and is going to make a
H3O.
neutral
Okay.
alcohol. Okay? So the nucleophile was not OH, but the result is the same. Yes or no?
Yes.
Okay? You want me to show you that mechanism?
Yes.
Outstanding.
Go to the board. I'll go to the board.
So, what's gonna happen next is, this is one of them, and the other one is, what, by the way, what's this? Retention of configuration or inversion of configuration?
Retention.
This is retention.
That's retention.
That bond is OH, and this bond was OH.
Yeah.
It's called retention of configuration. If I want inversion of configuration, I gotta draw this bond on the other
Other
side.
side,
Yeah.
So
yeah.
I'm going to go like this. Here's the OH, the H. Towards the back, I have the CH2, CH3. And towards the front, I have the CH3. Label this as R or S, R or S, and R or S.
Professor Garcia, when the additional water attacks and removes one of the hydrogens, it takes both of the,
One takes one.
so where,
The other one is the OH, right?
yeah, but I'm sorry, it takes, it
HCl.
breaks the bond between an H and the O,
HCl.
right?
Yes.
So where did those electrons go?
What electrons?
Because like when you did,
It took the H plus by itself. The electron stayed on the oxygen.
okay, so then wouldn't you need to draw the,
HCl? Yeah, I need to draw
And-
HCl, but
and put two dots on the O?
you know that they are there.
Okay, good.
I did not. Guys, you know, I'm supposed to draw here. The OH went here, yes? There's another H left and a Cl. Now, we already talked about this before, yes? Is HCl the organic product that we are looking for?
No.
Oh.
HCl is not the organic product. It is the correct thing to draw it, but I care about the organic product. Okay, so I most of the time omit it. I omit most of the rest of the garbage that happens there. If you want to learn that, then go ahead and read the book and memorize all of that stuff. So what's gonna be this? This was SN1, and this will be what? SN2. If it is SN2, what is it going to be?
A concerted
Inversion of configuration, yes?
right? And a
So you
concerted
are
step,
going to
right?
draw like this.
Mhm.
If that was here, then that's what you draw. And here is the H, and down here is the OH minus. Did you see that this was a nucleophile to begin with? We
Yeah.
have neutral nucleophiles, and we have what type of nucleophiles?
Charged.
Charged nucleophiles. When you're gonna put an OH, you can either do it with a neutral nucleophile, or you can do it with a charged nucleophile. Okay, the result is the same. And this here is CH2, CH3. And this here is CH3. Let's talk about RNS. Here is, can we do this?
Got it, good.
We can, I can't do it. If you're smart enough to do it, good for you. Okay? Since I can't do it, I'm going to redraw it. Look, I am going to redraw it. I'm going to exchange this H to put it in the back. I'm going to put it here. And this stuff went to the top. There's this OH and this is CH3. This is priority 1, priority 2, priority 3. The rotation is,
S.
this rotation is this way. It is S, which means that this is R. Are we going to do it here again?
No.
Why not?
Because you know that.
Yeah, that's just on
No, no, you don't know anything. What if you made a mistake here? You're going to redraw it. Why not? You guys lazy or what? It's too much work, huh? So here's 1, 2, and 3. What that is, that rotation is? R. That is this one. That's not this one. This one is S. Okay? Yes or no?
Yeah.
What was this to begin with?
You need a
An S.
drive.
Draw it,
I need to draw it?
redraw it.
Yeah.
R.
I don't know, you tell me if I should draw it or not. Is that okay? Is that okay? This rotation is?
S.
This rotation is S, so this is?
R.
And that is when you get 50% one and 50% of the other, that's called racemic mixture. Most of the time you do not get 50% of each. Okay, you get a little bit more of the inversion of configuration, but no big deal, okay? Racemic is what everybody wants you to know. And this one is inversion of configuration, yes?
When you conserve the configuration, you also conserve the RRS.
The what?
If you're conserving the configuration, are you also conserving R or the S thing?
You mean retention of
Retention, I'm sorry, yeah. When you retain the configuration, you also retain whether it's R or S.
Yes, that's what retention means.
So you don't need to, if you figured out the first enantiomer, you know that if you retain the configuration, you don't need to do the original.
And you can do the original. You should. I'm just not gonna do it, okay? That's your problem. That's on the test. Which nucleophile is better? This one is a better nucleophile. Is this a nucleophile? Yes or no?
Yes.
Provide the product for that. What is this going to be here? What type of reaction is this?
SN1?
You have to notice this is a primary alkyl halide.
SN2?
Primary alkyl halide gives you SN1?
No. SN2.
What'd you say SN1?
SN2.
We only look at the solvent when?
When it's
Secondary.
I mean,
When it's secondary.
when it's secondary.
Secondary. Yeah.
Okay. Will this go through an SN1 being a primary alkyl halide?
No.
No, it's not gonna go through an SN1, that's it, period. Doesn't matter what you use. Okay? So what is this going to give you? This is SN2,
SN2
because this
it's
is
a primary.
primary. And what you are going to do is, you are going to put the nucleophile. Which one is the nucleophile here?
The underwear.
CH3CO minus.
This is the nucleophile.
Yeah.
Okay? So what is gonna happen is, the oxygen is gonna go here, and it's gonna look like this, or better. look like that. Yes? Hello?
But you see how you got the.
That one wouldn't be stripped with an extra hydrogen.
Who is going to be stripped?
CH3 at the, so in the previous,
Yes.
in the previous,
The previous was neutral, this is negatively
oh,
charged
okay, so then
nucleophile.
we keep that, okay.
I mean, of course, there is a sodium here, right? Because that's not by itself. There's a sodium there, and the product is big enough, it's gonna be sodium chloride. Okay, how about this one? This is gonna be SN1, what's the
Yeah.
product?
OH with the CH3, OH.
The iodine is gonna go on.
Racemic, yes?
Yes.
It's going to be racemic, just like that one was what?
Inverted.
This was inversion of configuration, but this carbon here had two hydrogens, so was there any stereochemistry I needed to draw?
No.
There's no stereochemistry here. Is there a stereochemistry here that I need to draw?
No.
No.
No,
because
because you got
Yeah.
CH3.
I don't need to draw any stereochemistry. It doesn't matter if it's racemic or not. It is racemic, but it doesn't matter because you can't determine stereochemistry from here. So we just write what the product is, and the product
OH,
has the
yeah.
oxygen and the CH3. That is an ether.
No stereochemistry.
Yes or no?
Okay.
And of course, and HI, yes?
Mm-hmm.
Which I don't. You like that? Isn't that exciting? Is that exciting or no? You haven't been this excited in a long time, huh? That's the same thing, this is the same, this nucleophile is the same thing as saying this, yes?
Mm-hmm.
You understand that this negative has to have something next to it, yes? And that something has to be like a potassium or sodium, most of the time a group 1 cation. Provide the product for
So you
that.
just put Na just because it could have been anything else.
It could have been potassium,
Right.
I mean, it could have been lithium, it could have been cesium, but most of the time it's sodium. Because potassium is a little aggressive and explosive, and lithium is, the bond is a little bit strong. Not so ionic. What do you think, La Viste? Hmm? I know you do.
I gotta go to the bathroom.
I don't know, you never get constipated or anything, right?
I just drink one of those cans of Fixter from Mountain Dew. It's still coming in, so. Just kickstart some day.
So what's the product? What's this?
SN2.
This is the primary. The I is on primary.
So we are using here, like I said, it's somewhat difficult, yes? DMSO is conditions for
SN2.
SN2.
SN2
Two,
because
yeah.
it's polar.
Aprotic.
So what we're gonna have an SN2. If we have an SN2, what is the product going to be? Inversion of configuration. This is going to stay the same here, yes?
Yeah.
It's going to stay the same, but this would be inversion of configuration. What that means is that if I draw whatever it is here, would be the same thing as this, would that be inversion of configuration?
No.
That would be called retention of configuration.
Yeah, because you
Because
retain
this
it.
is SN2.
Yeah.
It's inversion of configuration, and this you are going to write here. Yes?
Yeah.
You're dying to have those on the test, don't you? You can't wait? Wait until we do eliminations. We are going to cry.
Tears of joy.
Tears of joy, yeah.
Curious, huh?
What's the product? You guys have a fixation on SN1, don't you?
It is primary.
So that's SN2? Okay. Yeah, I gotta be SN2.
This is your, if you better study this. Okay?
Yeah.
Because it's not good to feel like committing suicide later on. So, what are we gonna do here, my friends? It's SN1, SN2, or SN3?
SN2. Maybe
How do you
SN3.
know it's SN2?
Maybe SN3.
It's a
Because
primary
it's primary.
alkyl halide.
Yeah, primary alpha halide.
Since it's a primary alkyl halide,
It's under
going to be
SN2 conditions, right?
SN2 conditions, primary alkyl halide, SN2. So what are we going to write here? NH3?
And
No, what you are going to write here is NH2. NH2 is what goes there.
H.
So every time you substitute, you always take out one hydrogen,
If it's neutral, one hydrogen has to go.
it's neutral. If it's, like, let's say, negative, it's not.
It's
If
charged.
it's negative, no. If it's negative, it's,
Because
You don't
it's
have
already
to-
negative, you don't have to, okay, I get you.
you guys want to do a mechanism, yes?
Yes, please.
Outstanding.
I want to see a leaving group go and something getting pronated.
What type of mechanism do you want to do? Have we done any of the mechanism for SN1, SN2?
Not as yet.
I think we did.
No, which one? Please. No, we haven't done SN1 yet. Or SN2.
We did some of it.
She's always having something that anybody else doesn't have.
Say that again?
Guys, look in your notes. Have we done the mechanism for SN1 or SN2?
No, we just radicals, that's it. We haven't done SN1, SN2.
We used an SN1, but not SN2.
Yeah, that's just a structure. We didn't do the actual mechanism. When did y'all see a leaving group go and something get, yeah, y'all didn't see that.
Okay. Guys, we did do this mechanism, okay? There is not more. This mechanism is very simple. This is what type of alkyl halide?
Tertiary,
So what is going to happen is
it's gonna be a leaving group, right? Get out of here.
the I is out. And what you are going to form is a carbocation that is planar. It is trigonal planar. In the back, well, we did not want to worry about stereochemistry, so we have them everywhere is the same. This is positive. Now the water is going to attack.
Excuse me.
The water is going to attack. What part of the water is going to attack this?
The
The-
dots,
The oxygen, of course.
Yes, the oxygen with
the dots.
The hydrogens. The oxygens with the hydrogens is gonna give it a positive charge.
you mean the lone pair, yes? The dots are. Anyway, you can either attack with the dots from the bottom, or you can attack from the top. Which one do you like better? Huh?
On the top,
You like the top better?
missionary.
It does 50-50. It doesn't really care. It's gonna do same amount of times one, same amount of times the other. Actually, that's not true, but most of the time. So, if it attacks from the top, this is what you get. O, that attacked with a lone pair, hydrogen here, and hydrogen here. Does that have a charge, this oxygen?
Yes.
Yes, it
It's
has a charge.
positive.
Formal charge is positive.
Plus,
If
yeah.
you don't believe me, do the finger test, where I explained to you at the beginning of the course, yes? And that's CH3, CH3, and CH3. If the attack is from the bottom, I draw this line here, and then the other one from the bottom, most of the time, 109.5 degrees, yes? And this stuff is still going to go towards the back, and this towards the front. CH3, 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 and here's the new bond. The new bond is like this. That oxygen is charged. How's that? Yes?
Yes, sir.
And now every single time you have something that is neutral, when it gets attached in these substitution reactions, what is it going to become? It is going to become positively
Positive
charged.
charge.
It has to lose one of the hydrogens. So, who is going to take this hydrogen? Well, there is another water molecule somewhere with dots. Okay? And these dots, what are they going to do?
Attack.
What dots do? Which is, it will pull that hydrogen off. Yes? It's a proton. And what's going to happen to these two lone pairs right here?
Gonna go back on the oxygen.
They're going to go to the oxygen.
Oxygen, yeah.
Okay? When they go to the oxygen, now the oxygen,
Oxygen is neutral.
yes?
Yeah,
Now the oxygen is what?
neutral.
Is neutral. Okay? The same thing happens to the one on the other side. Most of the time, the one that pulls it is the solvent. There he goes, pulls this one, that one goes that way. How much you bet this is on the test? Any doubt to anybody here?
I bet my other leg.
That's outstanding. It's priceless.
Oh my God.
Okay, how's that, guys?
That was good.
You like that?
So you said most of the time the one that pulls is the solvent, right? When is
Yeah.
it like not?
No, it's all the time.
Most of, okay.
Sometimes you might develop something in there that is basic, like I minus,
Yeah, oh, okay.
but I minus is
Alright.
not strong enough to do it here. But sometimes it is. If you do electrophilic aromatic
Right.
substitution.
Which is coming soon.
But that's organic too, okay? So you don't worry about this. But in organic too, you are going to suffer the consequences of all three different intermediates on all three places of the aromatic ring. Okay, so that one's good, yes?
Yep,
Which one was this?
that's SN1.
SN1.
Yeah,
So would you like to do SN2 now?
yes.
Let's do SN2. So let's say I have this. you try to do it, okay?
Okay, so that's what concerns. Google.
Okay. All right, so what's gonna happen is, yes, there is the methanol there. This is a neutral nucleophile, yes? If it were charged, then the mechanism would be easier, yes? More than likely, I'll give you this one on the test. So I want you to do more. I don't want you to be disappointed to be taking this class. Is that what happens? It attacks,
Yeah. And then that in the leaving group.
and the leaving group
Goes.
does what leaving group do.
Yeah. In one step,
Yes.
right?
It bounces.
Mm-hmm.
That's, so, you want to draw it down here?
Yeah.
Something like that?
Yeah.
Yes? I
Mm-hmm.
mean, the fact that it left and I drew it down there, it doesn't make a difference, okay? I could have drawn it up here. Just drew it there, so you guys don't have this question later on. But this bond could be up here. So now what?
Positive.
So then it's
charge.
positive
This is
charge.
positively charged.
Yeah, the oxygen.
Cannot stay like that.
No.
So somebody comes and pull this off.
Yeah.
Who is going to do it?
The same
The
person.
CH3OH. Oxygen's gonna pull that H.
The electrons, that's not nice, yes?
No.
This one not drawn with love. There, from the middle. And the electrons are gonna go to that. And what are you going to get is, okay, you agree?
Yes.
She said she didn't.
So, let's say, look, once in a while I'm gonna do this, okay? Once in a while I'm going to say, provide the SN2 product. But once in a while only, okay? Don't get used to it. You sick? Students got you sick. 10:45.
Okay.
That was not a sneeze, okay, that was a cough. Okay, bless me for my cough, okay? All right. Thank you.
Man. This man noticed everything. Ah.
So what is it? What's the answer? Without thinking too much, SN2 is gonna give you
Inversion.
inversion of configuration.
Yeah. Yeah.
Yes?
Mhm.
Is that inversion of configuration?
Yes.
So I drew only one of them, okay? The other one you know that I did not draw was what? A hydrogen. Okay? And that's inversion of configuration. If I haven't said this before, I'm gonna tell you now. This here, N3 with a minus charge, is a very good nucleophile. Any nucleophile with a sulfur is a very good nucleophile, and they're not very basic, okay? So when you see those, what do they tend to do? Nucleophilic substitution reactions, okay?
Mhm.
I'm tired of substitution reactions. You want to do elimination?
Yes.
Wait, so that way you're just erasing right now, was that the mechanism of SN2?
Huh?
That way you just erased, was that the mechanism of SN2?
Yeah. Okay.
Professor Garcia, you said in a lab that Tossal, right, is the best leaving group.
Tonsil, no.
Tossal, right?
Yeah.
Tosselin?
Tossilate. Yeah, tossil.
Okay.
Yeah,
okay.
tossil. You can just call it tossil.
Okay.
Yeah, but I haven't shown you what it is because these are SN1, SN2. Most of the time it's an alkyl
They
halide.
like, okay.
We're gonna do tossil when we get to alcohols.
Okay, all right, got you.
Okay?